everybody, and welcome back to a fantastic Algebra 2 video. Yes, I know some sarcasm in there, but today in this video we're going to look at topic 2, lesson 5, example 2, and we're going to understand the process of what's called completing the squares. So completing the squares, we want to try to make a function into a perfect square and then whatever's left over. And so the first step of this is to do the completing of the square. So an example of a perfect square is something like x squared plus 4x plus 4, or x squared plus 6x plus 9, because in these cases, or even x squared, through our negative 1, x squared minus 4x plus 4. Because in these cases, these factors are 2 and 2, which gives us x plus 2 times x plus 2, or x plus 2 squared. All right, so this is considered a perfect square trinomial because when we factor it, we get a perfect square. Now, not all trinomials are perfect squares. We could have something like x squared plus 4x plus 5, where there's no two factors that can multiply to give us 5 and add to give us 4. So we're going to do what's called completing the square. Another good thing that completing the square helps us do is find the vertex form, because we will get it into this ax minus h squared plus k format. And this example is building our way to that. All right, so let's look at this. How can you complete the square to write an expression as a perfect square? So basically, how can you rewrite the expression x squared plus bx in the form of x plus p squared? Now, what we're going to do is we're going to look at this visually. We're going to look at it as, there's a solution. We're going to look at it as actual squares. So we have the first square, this first term right here. And that first term is created by multiplying two x's to find the area here in this square. So x times x gives us x squared. Now we're adding on b times x. So here's my rectangle, b times x. The area of this rectangle is bx. And I'm going to add that onto the square. Well, if I add that onto the square, we have a perfect rectangle. Let me extend that a little bit. We have a perfect rectangle, but we don't have a square. We don't have a perfect square. So what I'm going to do is I'm going to take this rectangle, I'm going to divide it into half. So I have this half right here. And now this is no longer the length of b, but now it's the length of b divided by 2. It's still this length of x, but the width here is b divided by 2. And now this other half, I'm going to take it, I'm going to rotate it. There we go. And I'm going to move it to the bottom of my square. Now this, again, this length here is b divided by 2, and this width here is x. So we still have this bx. We just split it into two pieces. And that leaves us this last little chunk, because again, we're still not a perfect square here. So we do have a little chunk here that I'm going to add. And this, if I look at my lengths and my widths, this is going to be b divided by 2 squared for the area. So for this full area, what we have here is x squared plus, let's see, we have two of these, 2b divided by 2x's. So I'm going to do 2 times b divided by 2x plus this last center, or this last square, which is b divided by 2 squared. Right, and this physically makes a perfect square. So these cancel out. We have x squared plus b divided by 2 squared. And the pieces that make up this, the length and the width of this, so this full length is going to be x plus b divided by 2. This full length here is going to be x plus b divided by 2. And so basically to get this area, this is the area right here, to get this, we're doing x plus b divided by 2 times x plus b divided by 2, or x plus b divided by 2 squared. I would put a star next to this. This is a very good setup for when we need to go into vertex form. If you could remember, x plus b divided by 2 squared gives us that perfect square. So part 2 of this, that was my writing from before, says how can you complete the square to write an expression as a perfect square? So looking at this, we have x squared plus 8x plus 5, and they want us to write it in this format. Well, if I factored the 5, it's only 5 and 1, and there's no other factors that go into 5 that will add to get me 8. So I'm going to start this completing the square idea. The first thing that I notice from this is that q is on the right-hand side, and there are no constants on the left. So I'm going to take this 5, and I'm going to subtract it. That leaves me x squared plus 8x on one side equals negative 5 on the other. Now I left this blank here because if we go back to this problem, to make that equation a perfect square, I'm going to have to take b, divide that by 2, and square it. So I got to take b, divide it by 2, and square it to give me that c value here. So I'm going to take 8, divide that by 2, square that, and I get 16. Now I can't just go and add values into my equation without it being a balanced equation. And right now it's not a balanced equation because I added this 16 to the left side of the equation. So if I added a 16 to the left, I need to balance it out by adding a 16 to the right. Now we have a perfect square here. And remember, I told you that x plus b divided by 2 squared is going to come back into play. So this is actually going to be x plus b divided by 2, which is 4, squared. And that gives us the left side. The right side is going to be 11. And we're done. We got it into the format they wanted us to get it in. If I wanted to see what the vertex was, I'm going to subtract that 11. And now I know my vertex is at negative 4, negative 11. So this form, this moving it into completing the square, can tell us a lot about the problem. It can actually help us solve the problem because I could take the square root of both sides and get x plus 4 equals positive or negative 11. And then x equals, the square root of 11. And then x equals 4 plus or minus the square root of 11. And these are the solutions to my problem. This is where my graph will cross the x-axis. So getting into the completing the square format is very helpful for us. Let's look at part 3. That's part 2. So they want you in the try to figure out how you can rewrite this in the form x minus p squared equals q. All right. If you have any questions, please let me know. But I hope you guys have a fantastic day.